Another example problem I'd like to take a look at for applications of differentiation. The cost of producing Q pairs of dress socks is going to be given by the following cost function. C of Q is equal to 20 plus 5Q minus 0.2 Q squared plus 0.04 Q cubed, which is just fun to say, Q cubed. We are going to find and interpret C prime of 10. So first off, if C is a cost function, which in this case it is, then C prime is going to be the marginal cost function. The marginal cost function is a rate of change of the cost per object that you're producing. So the interpretation of C prime of 10, this approximates the cost of producing one additional item. And in this case, that additional item would be one additional pair of socks. So really what this is doing is it's approximating the cost that it would take to go from creating 10 pairs of socks to 11 pairs of socks. So what we're going to do is find both and demonstrate how one approximates the other. So first thing I'd like to do is actually differentiate the given function with respect to Q. So that'll be C prime of Q, or the derivative with respect to Q, of 20 plus 5Q minus 0.2 Q squared plus 0.04 Q cubed. Hey, fun to say. So we'll go ahead and differentiate term by term. Derivative of 20 is a constant, so its derivative will be 0. 5Q with respect to Q will be 5 minus 0.2 times the derivative of Q squared, which will be 2Q, and then 0.04 times the derivative of Q cubed. That'll be 3Q squared. Then we can simplify this expression. This will be 5 minus 0.4Q plus 0.12 Q squared. Now this would be the marginal cost function. What we're going to do is actually plug in Q equals 10 and simplify this result. So this will be 5 minus 0.4 times 10 plus 0.12 times 10 squared. Now I'm seeing 5 minus 4 plus 12. 5 minus 4 is 1, plus 12 would be 13. That is a rather expensive pair of socks right there, not going to lie. Now with that in mind, let's see how it actually compares to approximating the cost of the 11th pair of socks. So that would be equal to C of 11 minus C of 10. That's the cost of producing 11 pairs of socks minus the cost of producing 10 pairs of socks. Therefore, that would be the cost of producing just the 11th pair of socks. So that would be 20 plus 5 times 11. This is going back to the original function, not to the derivative. Now for this, I'm going to be using my calculator to help me out a bit, so don't be surprised when that makes an appearance in just a moment. Because let's face it, we could do this stuff in our heads, but do we really want to? Oh boy. Alright, we made that fit. Okay. So here's what we'll do. We'll move that up here, like so. And we'll go ahead and do a couple of calculations. So first thing I want to do is calculate this first bad boy right here. So 20 plus 5 times 11 minus 0.2 times 11 squared plus 0.04 times 11. If you press math followed by 3, you'll get a cube. You could also do to the power of 3. So cost of producing 11 pairs of socks would be $104.04. And we'll go ahead and pop back over here and we'll plug in what we have here. So this is 20 plus 5 times 10 minus 0.2 times 10 squared plus 0.04 times 10 cubed. For that we get 90. So it looks like the actual cost of producing this many pairs of socks would be about $14.04. So the marginal cost that we got was $13, whereas the actual cost is about $14.04. Again, this is an approximation. It's not supposed to be exactly there. This approximation was off by about $1, so maybe not that great an approximation, but still allows you to interpret something where if you don't have access to a calculator, that becomes rather, well, complicated to say the least.